Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're going to talk about torque wrenches and their importance. So let's dive right into it. Now, what exactly is the problem that we need something fancy as torque wrenches? Well, reality is nut bolts, screws and fasteners, they are not magic, meaning just because you have them in a structure, in a building, in a car, in an electrical system, does not mean they will work. Meaning, if you tighten them too much, something will break. If you keep them too loose, something will break. So it's one of those equipments which requires what we call as just right. Meaning, if you have too tight, this could happen. If you have too loose, this could happen. It's one of those things that is like, you have to be just right. There is no hulululu into this. Like, you have to be right. You can shear a bolt off if you are like going all into it. You will feel good. You will feel strong about it. But here's the deal. You may have permanently damaged the bolt. It may not be at the, required strength. The engineer designed it like, this bolt will provide, let's say, X amount of strength. You overstress it. Now it's X divided by 5. Literally, it's like minor earthquake, which building was designed to be like GG, and here's the deal. Minor earthquake is like whole building falls apart. Yes, this sort of things have happened. That's how we learned the hard way, quote unquote. The bolts have to be torqued properly. Screws have to be torqued properly. All of these things are learned the hard way. We have to be very thorough about this. There is not something that, oh, just because you put it is now magic, it works. No. So what about this torque thing? Torque simply means energy. Basically, it's about a twist, how much oomph you're putting into it. All nut, bolt and fasteners, they have designed torque, meaning there is no torque specification. Basically, you cannot have like a screw could be designed for 5 Newton meter. Same size screw could be designed for 3 Newton meter. It's all in the design documentation, meaning depending on the application, depending on what the maker of that product, OEM of that product was thinking, they will design it in such a way. So you have to achieve that. Now, what does it guarantee you? Basically, let's say you achieved it, what they were asking. What does it give you? It gives you best and stable performance. Meaning, for example, in case of electrical work, it means there will not be any spark, there will not be a poor contact resistance. It will be as optimum as can be achieved. Again, it will not make your joints superconductor, but if engineers would have designed it properly, it would be like, you know what? If this you torque it to this much, it will have this much resistance, which is more than good enough, which is within the tolerance. There will not be excessive heating, there will not be sparks. It will be reliable. That's why people have to do it. And this in electrical is one of those things. In cars, you can do whatever you want to do with the steering wheels. The car will still stay on. If you do not torque it properly, either you can damage the bolt, in which case your wheel can go yeet, and you can have loose scenario, again the wheels will go yeet. So this is one of the scenarios where if you need best and stable performance, meaning you don't have to think about it, it has to be done properly, meaning all the design specification have to be followed. And for example, like this is one of the example charts that you can find in your MCB distribution box. It will say like, if you have MCB, common ground, RCBO, what kind of torques you have to use, like for, and what sort of cable also, meaning if you have 1.5 square mm cable, torques have to be this. If you have smaller than 1 square mm, this torques has to be used. So it is one of those things. And that's why we utilize tools specifically made for that, and we set it and then you go to town. For example, let's say you are working in a garage or working in a car manufacturing plant. You set it once and you just keep repeating it. That's the only way you can do it. You can't be like, doing calibration and testing on the equipment. You have to have something that allows you to achieve the torque that you need. So what sort of tool we utilize? Well, there are different level of torques. This is another aspect of it. Just because of the size, do not assume that you could have it's a small bolt, it has small torque requirement. Not necessarily, especially if you have like complex metals used. You may have a scenario where small bolt is taking GG amounts of torques, and where you have big bolt is like very little torque. It has happened, and it's one of those things that we learned the hard way. Just again, it's all goes back to the design documentation done by the engineer. So you will have a small screwdriver set, which are generally designed for a few Newton meters of torque. They are generally good for MCB, computer parts, and basically small equipment, basically things that you can hold in your hand, something like this. And you will find the insulated variant of this if they are designed for electrical work. So these are generally rated from like 1 Newton meter torque, or like 0.5 Newton meter of torque, to around 10 Newton meter, or even 12 in some scenarios. Then we have torque wrenches. These are for big players, basically tire wheels, big distribution box, things of that nature. They are designed for heavy use, where you give some love to it. And then you have power tools. For example, how the heck you gonna assemble a crane or bulldozer, or like things that have like really big bolts? You're gonna use this. Now you may have noticed, why the heck this hinge is there. If it was not there, it will twist your arm around. Like, you cannot provide enough counter force in order to, like, torque it properly. So they generally have a latch that you set it to the next bolt and then you twist it. They are designed in such a way that, like, they will always work. And if it's not, they may have a specific tool for that specific location, because you have to, your human hand does not have the oomph to it. Like, even if you are a WWE player, you still will not have enough torque in your hand where, like, you're counter torquing it. It's not going to work, especially with hydraulics or pneumatic systems. Battery systems is like almost geared down enough where you may be able to hold it. Pneumatics and hydraulic system, good luck with that. So these are the tools. There are generally 3 tiers of it. Like, you have screwdriver, wrenches, and power tools. So all of these are designed for repeatability, meaning you just keep doing it. You don't think too much about it. You set your wrench properly and done. You every day, like, again, till as long as you are using them, you can reliably be like, okay, I'm torqued this wheel. If the wheels are coming off, something else happened. Maybe corrosion happened, maybe some accident happened, but it won't be because you damaged the bolts. Bolts won't be the failing point for it, especially the tightening of the bolt. It won't be, oh, you over tightened it or under tightened. No, that would not have happened if you utilize this sort of thing. And if it still happened, and if your tools were right, that means the engineer messed up. It has happened. So that's the whole point of these sort of tools. And we come to the core aspect of it. Why these things are so goddamn expensive is because of traceability. You would have ever noticed a plane. It's not magic. It's not made out of magical material. Even though there's titanium, dude, you can find people who have titanium inside their body. It's not magical element. It's not hulululu. It's like stuff. It's like aluminum. It's not like magical. Heck, I have a bicycle that is made out of same aluminum used in aircraft. So it's not wow. But why the heck it's so expensive? It's because of traceability. And that traceability goes in every aspect, every nook and cranny of a aircraft, be it tires, be it electrical work, be it the multimeter that they used, everything has to be traceable. Because without traceability, all you are relying on is in hopes and prayer. What does that mean? That simply means, let's say you torqued a bolt that's supposed to be properly torqued at 30 Newton meter of force. Okay, awesome. The engineer designed it. If this landing gear is properly torqued to, all the bolts are torqued to properly 13 Newton meter, this puppy will perform awesome. But let's say a bad landing happened due to wind or something, but wheels started to fall off during the rough landing. How the heck that happened? Because bolt shear off. Why? Because you over torqued it. Now, how would you know? You must have used a torque wrench, like, you must have used it. But what if the torque wrench was non-traceable, meaning nobody checked whether the torque wrench itself is reliable or not? It may have over torqued only by few nanometer, but again, in extreme case scenario, it does amplify. So that creates a scenario. Or you could have a torque tool that was properly done, but it went through age, meaning it just aged. Tools do age. They are not made out of magic material. They are not made out of vibranium. They are made out of stuff that bends, that expands, contracts, corrodes, rusts. Things of that nature happens. Then you have misuse, meaning you can drop the tool. It is spring-based tool. Dropping it will change its behavior. You have normal wear and tear just by using it. You are using it properly, but you are still using it. It will still go through wear and tear. So even though right out of the factory, if it's done properly, absolutely perfect factory calibration, it will fade after a while. Again, depending on tools, some tools will flat out tell you, like, after 5,000 clicks, please certify it. After, if it's a really high precision, it's like after every 1,000, please recalibrate. So it's one of those things that you have to understand. And all good tools will require calibration periodically. There is no alternative. And that's why traceability is such an important thing. Meaning, no matter which brand of tools you are using, it has to be traceable. Now, traceable to where? That has to be done to the nation's metrology lab, meaning every nation has a central government based metrology lab. You have to show that I'm traced till here. After that is not your problem. How the heck you go to that location, that's up to you. But beyond it is not your problem. You're supposed to, like, as a company, as a multinational corporation, you have to show, like, let's say you are working in India, you have to show your metrology equipment. So basically Newton meter, torques, meter, feet, watt, everything has to be traceable to the India's national metrology lab. If you are in USA, you have to show traceable to US metrology lab. That's all you have to do. Trace it to the basically location national metrology labs, and you have to do it periodically, and you have to test it on your equipment, on yourself, where it's like, dude, I think this is a very high requirement. For example, if you have a sloppy tool, it will say 6% plus and minus. If you have an okay tool, it will say 4% plus and minus. If it's a really good tool, it's a 2% plus and minus. If it's a really high precision tool for, like, multi-billion-dollar jet, at that point in time, it will say, you know what, plus and minus 1% or plus and minus 0.5%. In those sort of scenario, you no matter which company tool levels, they will say, dude, use as much as you want, but please test this puppy every month. They will not even wait, allow you to go for 1 year. They're just 1 month, just do it. Just do it. Just get it fucking calibrated, or we'll void it. And at that point in time, the person responsible for the logistics will get blamed, not the company, not the workman. It's like there are people who is responsible for the tool maintenance. They have to be reliable there. So all the critical applications require repeatability. Now, does this mean there will never be a bolt that is? No, hell no. That's not going to happen. Physics does not allow. But idea is that, let's say a plane has, let's say, 800 bolts. At least 99.99% of the bolts will be precisely done to precisely what they need to be. So in case one bolt does fail, it will not have a catastrophic failure. So that's why traceability is important. That's why, like, whenever you hear people say, like, B2 is so more expensive compared to, like, even just made out of gold, that's the reason. Every tool used to make that B2 would have had this sort of traceability. Every wrench, every multimeter, everything that was used to make those things were traceable to the National Metrology Lab. And they will have less steps compared to the normal step. You could have like 3 to 4 steps until your multimeter, there could have been like direct, your multimeter was sent to National Metrology Lab if they are damn serious about it. And again, especially with electronics, and when you're talking about like logic levels that are like 3.3 volts, they do require a lot of calibration. So traceability does matter. So what we can expect in the future, it is one of those things that are becoming more and more important as time goes along. We are no longer accepting sloppy things. We are not just rhyme that puppy. We are no longer accepting, because we have learned it the hard way. It's just not good enough. That's the reality of it. It's becoming such a big part where normal home electricals are showing you torque requirements, and EV outlets are, they are damn sure. And this is one thing that I learned the hard way, is that when you have a gasket is designed to be crushed. Again, they are generally designed in such a way that it's gonna fill up the place. But here's the deal: if you over crush it, for some reason they also fail. If you over crush it, they still fail. You under crush it, they still fail. It's not like, just go all ham on into it. No, it's one of those things. Like moisture can get in, especially if you over crush it. So it has to be done properly. And digital torque wrenches are taking over at this point. Like, this is Milwaukee. Milwaukee. I have provided a video down below, and you can see that, like, they are designed for, like, if you are working a lot, why the heck you will do. So it will have electrical motor that will torque it to its closest destination. Meaning, if it's supposed to be 15 Newton meter, it will take the electric motor will torque till 14 Newton meter, and after that you have to apply the manual pressure. And because that gives you enough leverage, you can see it like yellow, 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 green. That's how it does. So it gives you enough leverage where it's like not over tightening it. Then we come to another aspect. Many places where you have to be absolutely reliable, OEMs are using what we classify as shear bolts, meaning you put the bolt, you go ham on it. You just go YOLO on it. They know for a fact that humans like to break things. So you have a nut bolt, you put your socket wrench, and you just go. You just put love into it without thinking about it. And when it reaches the desired amount, let's say 50 Newton meters or 100 Newton meters, it will just snap off. You don't have to think about it. And when you have snapped off the bolt, that's the easiest way to share. It's confirmed, it's properly done. So a lot of OEMs and high electrical loads are doing that. And practitioners, basically people who are using screws and bolts in any sort of application, be it car, be it electrical, be it computers, you would have noticed that server processors, generally high-end ones, like AMD ROM processors, they had a torque screwdriver built into it. Because think of it this way: you messed up a goddamn motherboard and a super expensive processor because you over torqued it or under torqued it. That's not acceptable. So they are like, dude, this product is expensive enough. Putting one torque screw that is made for only one torque setting is acceptable cost. They're like, just put it there. That's just like, put it there. So that's why, like, you will see like this sort of tiny thing. Because if you are a factory that are working on like bespoke elements, you do not want to mess around with it. Just get a goddamn properly traceable screwdriver. Then at that point in time, you can reliably work on it. And again, follow the manufacturer's requirement. Manufacturer will say, dude, after 5,000 clicks, please get it recertified. After let's say 1 year, please get it recertified. So as a practitioner of people who are dealing with the nut bolts and screws, we have to become more aware of it. It is becoming more important discipline of the job. Basically, it's like part of the job. You have to be aware of these things. We are no longer just tolerating ham into it. So this was my presentation on torque wrenches and why they are becoming so important. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.